Alright, ladies and gentlemen, today we're going to be talking about frequency and histograms. You've done both of these things before if you took 7th grade math, but we're going to get back into them and redefine them and make sure that you remember what to do with them and how to make them especially. So first I've got a bunch of vocab for you. Feel free to pause this video if you need to write it down. So the first one is stem and leaf plot. So a stem and leaf plot is a T-shaped plot to organize data. A T-shaped plot to organize data. It can be a T with data on two sides or a T with data on one side, but it's got that same shape every time. The next vocab word I have for you is frequency. So frequency tells us how often a certain type of number occurs in a data set. So I'm going to call that a proportion for how often. The proportion of a certain category in a data set. So frequency is just the idea of this proportion, but we can use the frequency to make a frequency table. So this is a pretty self-explanatory one. A frequency table is a table of frequencies of a set of data. So it's a table of frequencies of a set of data. And then taking it one level further, let me zoom this in a little bit. Taking it one level further is a histogram. So a histogram is the way that we would graph a frequency table. So we can plot everything onto a graph, make a visual representation using a histogram. So I'm going to call that a graph of a frequency table. A graph of a frequency table. So today we'll be making stem and leaf plots, frequency tables, and histograms. Go ahead and make sure you've got all that vocab down, and we'll move it down to make a stem and leaf plot. I'm going to zoom it out again so we can see a little bit of both sides of our paper. When we make a stem and leaf plot, we want to first sort the data into categories. And the categories we want to use are the categories of the size of our numbers. So for example, I'm going to make a category of the numbers we've got in our set of data that are between 0 and 10. So that's going to be my first category. So I've got an 8, I've got a 9, I've got another 9, I've got another 8. So those are my categories between 0 and 10. I'm going to make another one from 10 to 20. I guess in this case, it should be 0 to 9 and then 10 to 19. We want our numbers at the beginning to be the same. So here's all our zeros, here's all our ones. So we've got 14, 12, 13, we've got 15, we've got 13, and we've got 19. So those are all my teen numbers. The next category I'm going to do is 20 to 29. So there's my 20 and my 21. So I've got all of my data sorted into categories based on the size of the number. The next thing I want to do is I want to draw my stem and leaf plot. So my stem and leaf plot is a T-shaped chart. So here's my T-shaped chart. But I'm going to make one side of my T a lot longer than my other side here, because one side of this T is going to represent the first digit of each number in our information, in our data. So here I've got 0 through 9, so we'll call that starting with 0. It's less than 10. Then we've got 10 through 19, that's like starting with 1. And then we've got 20 through 29, so those numbers start with 2. So you can think of this as the tens place of our data. After we get our tens place, we're going to come over to the other side of our stem and leaf plot, and we are going to write our ones place. So we have 8, 9, 9, and 8. And I'm going to write those in order from smallest to largest. So I've got 2 8s and 2 9s. I'm going to write 8, 8, 9, 9. Then I've got my tens place. I've got a 2, a 3, a 3, a 4, a 5, and a 9. So again, I'm writing them from smallest to largest. So I'm going to say 2, 3, 3, 4, 5, 9. Okay? And then I've got my 2's, my 20s. So we've got 20 and 21, so I've got a 0 and I've got a 1. And that's my completed stem and leaf plot. I also do want to make sure that I put a scale down here, and what they mean by scale is showing what size these numbers are. So I might write 1 scaled with 2, that would be like my first data point right here. That's going to equal 12. Because in some stem and leaf plots, we might be dealing with bigger or smaller numbers. And the 1 scaled 2 might be equal to 1.2 instead of 12. So this just shows us the scale of our stem and leaf plot. A stem and leaf plot is a good way to show where the data lies in a certain data set. So we see that most of our data is on the beginning side, smaller number side of our data set, and there's very few that are up here in the 20s. A stem and leaf plot is also good when comparing two things. So down here we've got the season scores for football teams going to the state championship. They're given below, and we're using the data to make a back-to-back stem and leaf plot. So we're going to plot both of these data sets on the same stem and leaf plot. So when I do this, I'm going to say Team A is going to be over here, and Team B is going to be over here. And I'm going to organize the data the same way I did before. So as I look through Team A's data, the smallest data points that I have are in the 40s. So I'm going to come down here, and I'm going to say 40s, and I'm just going to do that so I can remind myself that those are in the 40s. So I have 42, 49, 42 again, and 45. And I'm going to cross all those out. I've got a 42, 49, 42, and 45. So now my 40s are taken care of. Then I'm going to get my 50s. And here I have a 56, 58, and 55. So 56, 58, and 55. And again, I'm going to go through here and cross those out. 56, 58, 55. I've got data in the 60s as well, so I'm going to give myself a 60s category. And that's going to be 65 and 61. So I've got to cross out 65 and 61. And then finally I have one data point in the 70s, which is the point 72. So then I've crossed out my entire top row data set. I know I've gotten all of that accounted for. Let's take a look at our Team B data. So once again, the smallest numbers that I've got in here are in the, let's see, in this case, they're in the 30s. So I'm going to give myself a 30s category, and that's 37. Then I've got numbers in the 40s. And in the 40s, I've got 48, 49, and another 48. So 48, 49, and another 48. Again, I'm going to cross those out. 48, 49, and another 48. Then I look for the data in the 50s. So in my 50s, I've got 57, 52, and 58. So I'm going to cross out 57, 52, and 58. And then finally, I'm going to do the data in my 60s. Let me zoom this in again, that way we can see this. So in the 60s, I have 60 itself, 61, and 63. So 60, 61, and 63. Now that I've organized my data, I'm going to write this as a back-to-back stem and leaf plot. So this is where this T shape of my table really comes in. I'll zoom this back out. So we're going to come over here, and we are going to make this T-shaped table. So we've got two lines in the middle of our T. And in between these lines, that's where we're going to put the data about the tens places of our information. And I might write on here, I'm going to write this is Team A and this is Team B, so I know which side represents which football team. And I'm looking for my tens places. I see 40s, 50s, 60s, 70s, but we also have 30s, so I have to make sure to start my tens place with a 3 for 30s. Then I've got 40s, 50s, 60s, and 70s overall. Now that I've got all my data, I'm going to plot it. And since I have a back-to-back stem and leaf plot, and plot A is going to the left, when I write my order of my numbers, I'm going to make my smallest number closest to my middle line, and my bigger numbers go outward. So Team A doesn't have any data in the 30s, so we can leave that blank. But it does have data in the 40s. It's got 42, 49, 42, and 45. So I see a 2, a 2, a 5, and a 9. I'm going to write them closest first. So 2, 2, 5, and 9, just like that. Then I look for the data in my 50s. I've got a 55, 6, and 8. So I'm going to say 5, 6, and 8, just like that. Then in my 60s, I've got a 1 and a 5. So I'm going to write 1 and 5. And in my 70s, I've got one data point, and that's just a 2. So 72. So that's half of my stem and leaf plot filled out. Then I've got to take a look at the data for table B. And for B, I do have one data point in the 30s, and it's 37. So I'm going to say 37 is my first data point. Then I've got an 8, a 9, and an 8 in the 40s. So I'm going to say 8, 8, 9. I've got a 2, a 7, and an 8 in the 50s. So I'm going to say 2, 7, 8. And then I've got a 0, a 1, and a 3 in the 60s. So I'm going to say 0, 1, 3. So that's my completed stem and leaf plot for my football teams. When we take a look at this, we can compare certain things. We can compare that Team A seems to have higher scores overall than Team B because their data falls lower in general on our stem and leaf plot. Team B ends up with the lowest score overall, and Team A has the highest score overall. So we can compare our two teams with that back-to-back stem and leaf plot. Another example I want to go over is how to make a frequency table. So this frequency table tells the number of students enrolled in Western civilization classes at a university. So we've got different numbers of students that are enrolled in classes. So like I've done before, I'm going to make the same categories of data. So I'm going to categorize my data 0 through 9, 10 through 19, 20 through 29, and 30 through 39. Because we like to keep our first digit the same. So all of these have a first digit of 0, first digit of 1, first digit of 2, first digit of 3. So instead of writing exactly the numbers that are in my data here, I don't need to write those exact numbers. I can just count how many data points that I have that are in between 0 and 9. So here I see one data point in between 0 and 9. So I'm just going to write, let's see, the number 1 right there. Then I'm going to look between 10 and 19, and I see 1, 2, 3, 4 data points between 10 and 19. So I'll write a 4. I'm looking between 20 and 29, so I see 1, 2, 3, 4, 5 data points between 20 and 29. And then I'm looking for 30 through 39, and I see that there's 1, 2 data points between 30 and 39. So these are telling me the frequencies. This tells me the amount that these data points show up. So 0 through 9 shows up once, 20 through 29 shows up 5 times. This is a more common class size than 0 through 9 students. Once we've got our information laid out like this, we are going to make the table. And making our frequency table just really means taking our information and presenting it in a different way. So I'm going to make a table. And on the left side of my table is going to be my categories. So remember that these categories stand for number of students. So I'm going to call that number of S for students. And on the right side, the information that I've collected is the frequency, the amount that these numbers show up in our data. So I'm going to call that the frequency. And we're really just going to rewrite our data over here. So number of students 0 through 9, there's one class with that size. Number of students 10 through 19, there are 4 classes with that size. Number of students 20 through 29, there are 5 classes with that size. Number of students 30 through 39, there are 2 classes with that size. You don't always need a 0 through 9 or a 10-number range when you're making a frequency table. If you have a lot of data that's bunched up together, maybe you want to make your frequency categories smaller. Maybe my categories could be 0 through 5 and 6 through 10 and 11 through 15 and 16 through 20. I could go by 5s. I could go by 3s, depending on how much data you have in a small space. It's usually good to have 4 to 6 categories when you make a frequency table. So here I've got 1, 2, 3, 4 categories. Go ahead and turn your paper over once you've got this finished, and we're going to talk about making a histogram. So a histogram is just a graph made with the data of a frequency table. And it is a bar graph. We're going to make our normal axes for our graph here. Since we have a real-world situation, everything we're talking about is positive numbers. We don't need to make the other coordinates of our graph. But we do need to make our categories. And when we make a histogram, the unusual thing compared to how we would normally make a graph is that our categories go in between the spaces. They don't go right on the line. So this line doesn't represent the category 4 through 6. This space represents the category 4 through 6. Then I've got another space, and that represents the category 7 through 9. I've got another space to represent the category 10 through 12. And then finally, I've got one last space to represent the category 13 through 15. Right? On the y-axis, we can just do this like we would normally do. I have frequencies between 2 and 5, so maybe I'll just label this from 0 to 5. So I've got 1, 2, 3, 4, 5, just like that. So I might label my axes, so I've got interval down here. And I knew that because we have the label interval here. I've got frequency on that side. So interval and frequency, I'm going to make some bars now. My lines are not the categories. The spaces in between the lines are. That means that my bars have to be a little bit wider to show this. For example, I've got 5 frequencies in my 4 through 6 category. So I'm going to come over here and I'm going to make a big wide bar that goes all the way down to the line in between my categories. So that's 5. That's my frequency of 4 through 6 day vacations. Then down here, my next one is 7 through 9. I'm going to make a line that's my bar here that shows that my frequency is 4. Same thing with 10 through 12. I'm going to connect this line over. Got another frequency of 4. Make sure my bars are wide enough to cover that whole category. And then I've got 2 in 13 through 15. So I'm going to come down here and make a 2, just like that. And that's all you have to do to make a histogram. That just shows what sort of categories we have, but in a visual way. We can see that most of our categories, most of our data rather, is sort of in the beginning. So the vacations, Julia's last vacations, end up being 4 through 6 days most often, and not as often are they 13 through 15. In your homework, you'll have to answer questions about some of these as well. You'll make some of these graphs, and then you'll also answer questions about them. Right? If you have any questions, please make sure to let me know. Thank you.